We're going to do a hypothesis test for a mean. There's really three major kinds of hypothesis tests we can do. We can do hypothesis tests for proportions, we can do hypothesis tests for means, and we can do hypothesis tests for standard deviation. But right now we're going to do a hypothesis test for a mean. And there are really two kinds of hypothesis tests for means. And it all depends on sigma. You see right there. Sigma is the symbol for the population standard deviation. And if we know sigma, then we use a z-test to do the hypothesis test for a mean. If we don't know sigma, we use a t-test. So we're going to be using a z-test because in this problem sigma is known. And by the way, this presentation is going to be in two parts. It's pretty long. So we're going to break it up into two parts. I'll call this part 1. So you see what it says here. This is the book we're using. Chapter 8.4, testing a claim about a mean. Sigma is known. We will use the p-value method. Here's the problem, and this is out of the textbook. Problem 14, weights of bears. The health of the bear population in Yellowstone National Park is monitored by periodic measurements taken from anesthetized bears. That means the bears have been knocked out. A sample of 54 bears has a mean weight of 182.9 pounds. Assuming that sigma, and there's our sigma, is known to be 121.8 pounds, use a 0.05 significance level to test the claim that the population mean of all such bear weights is greater than 150 pounds. I want you to notice that I've highlighted the words test the claim and mean. These are the most important words in this problem because they tell you what kind of a problem it is. When it says test the claim, you know you're going to be doing a hypothesis test and not a confidence interval. When you see the word mean, you know it's a hypothesis test for a mean and not for a proportion or for a standard deviation. So the first thing I do whenever I'm going to do a hypothesis test is to create a checklist. And here you can see my checklist down here in the lower right hand corner. This is very important as a way to keep track of what you're doing and frankly to sort of keep your sanity while you're going through the process. So usually I actually start with the sample data. So we'll see that here. What are the sample data? You can see that. And we get all the sample data right from the problem. It's all there. And it tells us that the sample has 54 bears. So n equals 54. It tells us that the mean of the sample is 182.9 pounds. That's x bar. X bar is the mean of a sample. And it tells us that sigma, the population standard deviation, is 121.8. So that goes there. And you'll see I keep repeating this because it's so important. Since we know sigma, the population standard deviation, we will use a z distribution when we get there. But let's keep going. Oh, by the way, we now know our sample data. So I'm going to come over here and put a little check mark in the sample data box. So we're making some progress on our checklist. What's next? What is alpha? Well, if we come back here in the problem, you will see use a 0.05 significance level. Well, that's alpha. The symbol for significance level is alpha. So down here I've noted alpha is 0.05. So I'm going to check off alpha on our checklist here. So we're making good progress. Now, what is the claim? We know the claim in words. The claim in words is that the population mean of all such bear weights is greater than 150 pounds. But we cannot put that into the calculator. The calculator doesn't understand English, doesn't know words. So we have to come up with another way to put that claim into the calculator. And to do that, I use something I call the claim buffet. And that's over here. You know what a buffet is. You go and they have tables, and they have a meat table and a vegetable table and so forth. So we have tables in the buffet. We have 3 tables. 1, 2, 3. The first table, our choices are going to be P for population proportion, mu for population mean, and sigma for population standard deviation. Our claim could be about any of those. And by the way, the claim is always about the population. There's no such thing as a claim about a sample. On the second table, we have all these things: greater than, less than, not equal, and equal. And on the third table, we're just going to put whatever number is in the claim. So here if we look at the claim, we see the population mean. Well, that's a really important word. That tells us that when we come over here, we're going to choose mu, which is the symbol for the population mean. The next table, what are we going to do? Look over here again at the claim in words. Is greater than. Well, that's what this symbol right here means. Is greater than. So we're going to circle that. And then what is it greater than? It's greater than 150 pounds. So 150 pounds is going to go right here. So if we put all these things together, our claim is mu is greater than 150. So we are now done with our claim. So I'm going to check that off. And finally, we need to create our hypotheses. And we do that from the claim. What are the hypotheses? So here's the way you want to set this up. If you want to keep it straight, not get confused, this is the way to do it every time. So here's our claim. We already talked about that. The claim is that mu is greater than 150. Right under the claim, you want to write HO, and under that, you want to write H1. And then you'll notice both of the hypotheses start and end the same way as the claim. The claim starts with mu and it ends with 150. Well, guess what? HO starts with mu and it ends with 150. H1 starts with mu and it ends with 150. But we got to figure out what's going to go in these places here. And the way we do it is this. We need to find a home for the claim. The claim is sticking up here but doesn't have a home. It has to live in HO or it has to live in H1. And the way we decide that is over here, this tells us all of the things that can live in HO, and this tells us all of the things that can live in H1. So if we look at this greater than, the only place we find that over here is right there, which means this claim is going to have to live in H1. So we're going to put that right there. Now we're just left with HO. You could put in HO either of two things. You could put the true complement of this, which would be this, less than or equal to. But as a matter of practice, and in fact the way your online homework wants you to do it, is you just put an equal sign there. So now we have our hypotheses. HO, the null hypothesis, mu equals 150. H1, the alternative hypothesis, mu is greater than 150. And by the way, sometimes some teachers, instead of saying H1, they say HA, A for alternative hypothesis. So I'm going to check off hypotheses now. There we go. And now we're ready to actually go to work and solve the problem. And that's going to be part 2 of this presentation. So I'm going to end this presentation now, and then for the rest of it, for how we actually solve the problem, you'll go to part 2.